We are going to discuss about control charts for attributes. In the previous classes, we were discussing about the control charts for variables. The main difference between the control charts for attribute and control charts for variables is the quality characteristics, as we were discussing about. If the quality characteristic is a miserable one, then we'll be using the control charts for variables. If they are not miserable one, which cannot be measured, their quality characteristics, which can be classified as defective or non-defective. Try to understand. There will be only two outcomes. One is either it is defective or non-defective. Then we are going to use what are called as the control charts for attributes. The control charts for attributes are, or if I draw these things, the control charts, that is what I started in the previous class. So we have had this particular type of the flow chart. Control charts, it might be control charts for variable, attribute. Again, I will say that based on categorizations, it becomes very easy to understand the things. Otherwise, it becomes difficult. So that is why we go on classifying them as based on, this is based on quality characteristics. Whether the quality characteristic is a miserable one, if it is a miserable one, we classify it as control charts for variables. If it can be only counted and like that, which cannot be measured, if the quality characteristic is attribute type, then we can call it as, we can go for attribute control charts. The attribute control charts are four types. One is P chart, another one is NP chart, third one is C chart, and the fourth one is U chart. Whereas in case of control charts for variables, we have seen that there are four types of control charts. One is X bar chart, another one is R chart, and the third one is the sigma chart. Okay. Now, what is the difference when we should go for control charts for variable and when we should go for control charts for attributes? At the outset, I can say that if we have the detailed information about the full information about the quality characteristic of a particular product, that means if most of the rejections are being taken place, or most of the time the product is being rejected for not meeting a particular quality characteristic. Say if it is a shaft, then the dimensions of its diameter it is not meeting because it is being rejected because of not meeting the dimensional tolerances on the diameter more than its length or surface finish. Then the control charts for the diameter dimension only will be produced, because we know about 90% of the times it gets rejected because of for not meeting those dimensional specifications on diameter. Okay, in that case it becomes easier. But whereas the components are being rejected for not meeting the measurable characteristics. For example, in some assembly, there might be some 50, not 15, 50 measurable characteristics in some big assembly. Then does it mean that for each of these dimensions we are going to maintain the control charts? In that case, it becomes economically not viable, because friends, all these things will depend on the economics only. Whether we should go for the sample inspection or the 100% inspection, that itself can be answered going through the analyzing it on economical basis, because that is what we say, that objective based in the sense. Because here we don't give much importance for emotional basis and other things, quotients and other things. It is objective oriented. Is it economically viable or not? Emotional decisions will not have any role to play, in fact, in the present day's circumstances. Okay? So it is based on a rational basis. What rational basis? That is what we say, because it is based on the rational basis. What rational basis? Rational basis will consist of these numbers. And we are going to play with the numbers, that is what on the statistics. Hence, the measurable characteristics or whatever it is we are going to consider, and then rational basis in the sense, is it more beneficial or less beneficial, the economy wise. If I am going to spend small amount and if I am going to get more amount, that is more viable than something else. Okay? That is how everything is to be compared against a common yardsticks. That is what I told you in the previous classes as well. The decisions are made based on the common yardstick, which is the monetary benefit. So monetary benefit is easily measurable, whereas other things, they cannot be measured, because intangible things cannot be measured, cannot be quantified, whereas tangible things can be quantified. Okay? That is why when to go for control chart for variable and the attribute, it depends on that. But to tell you the facts, if the institute or the industry or the organization, it wants to control its measurable quality characteristics, say for example, the absenteeism in the organization. But don't be understand, because that might be the problem in service sector. If the people are absent, then how we are going to carry out the things? Okay? Where are the other quality character and other things? Okay, measurable, because the absenteeism, how we are going to control that? If the people turn out for the work, then only the things can be done properly. If they are not turned up, then what is the happy situation? When do you say that there is a lot of absence and most of the people are present and other things? That means we are going to fix the limits. If it falls below a particular limit, no, because everything there also, absenteeism is also, it is going to be vary. It goes on varying. Because we cannot expect that, or even in this class, we cannot expect that all the 60 students will be present on any given day. We'll have some 10 plus 10 or minus 10% absent variation will be there. That is going to be, in this case, it cannot be 60 plus 10, 70, it cannot be. Okay, we can say that sometimes it will be, it is going to vary between 50 to 60 students. That is what we say. Is it not? It is just like that. But if it drops down to the number of students present in the class, it is going to be only 25 or 30. That means there should be the reasons can be assigned for this. Why? The same is true in case of the other product quality characteristics. In service quality characteristics, it is naturally the number of people present. That is what I mentioned. That means like that. Oh, okay. In case of product quality characteristics, collectively we can classify the product as defective or non-defective. It might be because of several defects or defectiveness present in that particular product. Okay, that is how we are going to classify. So, if I come back to the previous example of that large assembly, which has got some 50 measurable quality characteristics, if I adopt control charts for variables, then I may have to maintain 50 separate control charts for these different quality characteristics, which will become more costly affair. One thing. Second thing is, they may not be being rejected for all these 50 quality characteristics. Only few quality characteristics are more important. So that is what could be revealed by first maintaining the control charts for attributes, and then in detail if we want to analyze it, then go for the control charts for variables. That means the maintaining the control charts for attributes, it becomes more economical, but the less information we can generate. So in order to have the happy situation, first the thing will be introduce the control charts for attributes, and then if we come to know that the things are being rejected or being classified for a particular measurable quality characteristic, then try to maintain the control chart for variable for that particular measurable quality characteristics. It might be one or two measurable quality characteristics, and then it becomes more viable. So, in other way, putting it in other way, for cursory analysis, first we'll begin with control chart for attributes, then we zero it on, then we go for control charts for variable. That means cursory, that control chart for attribute for cursory analysis, and control charts for variables for detailed analysis. That is how we can control the quality effectively. That is the crux. But when we started first with control chart for variable, and now we are studying control charts for attributes. That is what usually happens. Okay? While planning, the things would be like that. When we want to implement, it will be other way around. That is what I might have given an example of construction of the building. Okay? When we want to plan, we will never plan with how much depth of the foundation would be. Okay? First we will know how many these things, the story of the building, if the stories are multiple storied building, how many stories are required. That will calculate depending upon our availability of area and to how many people we are interested in providing the accommodation. So it will be, while planning, it is top-down approach, while implementing, it is bottom-up approach. When we start constructing, when we start planning, it is from the top down. When we start implementing or constructing, it is bottom up. That means in case of building the building, we will not build it from the top. We have to build it from the bottom. That means foundation. Likewise, when it is to be, because we studied that one first and now we are coming back to control chart for attributes. But when we want to implement, which one is to be implemented, first we will go for control chart for attribute, and then we will end up with implementation of control charts for variables. For a simple reason of economics or economical reasons, that is what is to be done. Okay, is it understood? This is the whole crux of this. These are certain advantages and disadvantages. And when to go for control charts for variables and when to go for control charts for attributes. That means control charts for attributes, when there are many quality characteristics, or some of them may not be able to measure it. And the third aspect would be, most important, is economical aspect. Okay? And this will cost less. Control chart for attribute will cost less. And another thing, if you look at it, what about the sample size? What about the frequency? What about the subgroup size? or sample size or the sample size, and what is the frequency and what is the time of collecting these things. That is what? The samples. Usually, the sample size for control charts for variable is less, and mostly it will be hovering around the sample size of 5. Whereas the control charts for attributes, it will not be like that, especially P chart or NP chart. The sample size has to be large. Try to understand. What is meant by large and small? Usually large in the sense more than 50. Okay? So those sample sizes will be usually like that. Okay? So it might consist of 100, 200, 300, 2000, like that. Why? Let us find out. Suppose a company is manufacturing the fraction defective of 0.001. What does it mean? P is equal to 0.001. If I take only one sample, if I take a sample of 5 here, what is going to happen? If you look at it, the sample of 5, if I take, it may contain 0 defective. Then we say that everything is perfect, it contains 0. Out of 5, I don't find none of them is defective. Okay? Then it is perfect. And sometimes I get, out of 5, 1 is defective. That means, what is the percentage of defective? It is going to be 20%. Try to understand. Only one defective is found. It will tell us that it contains 20% defective. But in reality, out of 1,000 items, P is equal to 0.001. That means usually it is expressed, P is expressed in fraction defective, or it is the percentage defective. Both the things I have noted down here. P is equal to 0.001. This is the thing. Or if I want to maintain about the percentage defective, that I can do by multiplying it by 100. That is what we can do. So usually while calculating or establishing the control charts, we are going for fraction defective. This means out of 1,000, 1 defective is there. So what should be the adequate sample size in that case? At least I should be able to collect 1,000 samples. At least 1 defective I should find. If I take only 100 defectives, no, I cannot find. If I take only 10, we may not be able to find. So the sample size depends on that. If it is P is equal to 0.01, or you can just go on thinking like that. P is equal to, then we can establish certain relationships. 0.01. P is equal to 0.02. Try to understand. P is equal to 0.01 means at least I should take a sample size of 100. Then only I am going to get at least 1 defective. P is equal to 0.02, at least 50. How do I find out? Just think about that. What this one? What should be the sample size? It depends on these things. Okay? So, if it is closer and if P is equal to 1, don't say P is equal to 100%. P is equal to 1 means 100%. So, 0.1, we can take about 0.1. That means 10. Okay, then I'll get a defect. But usually it will be around this one. So the sample size here would be around 100 to 200 units like that. Because based on the sample size, the accuracy will go on varying. Or drawing the inference, it depends on the sample size. If the sample size is more, then we can draw a better conclusion If the sample, that is what I'm talking about in case of control charts for attributes. If the sample size is small, we may not be able to draw the better conclusion because of the reasons I told you. So generally, the sample size for control chart for attribute is more, maybe in the range of 100 to 200, something like that. So when we go on solving the problems, we will come to know about it. Okay, friends, is it understood? So that is, one is the sample size. Next one is, that means how many subgroups. Now we talked about sample size means it is subgroup size. Next one is, how many subgroups. So usually these subgroups will depend upon daily production or the shift-wise production or weekly productions or monthly productions like that. Try to understand. So much variations. There, in control charts for variables, it was not like that. Only hourly or 2 hourly or something, because sample size used to be small. Since the sample size here is more, then likewise the things will also be, the duration or whatever it is, frequency will also be moving. So usually it is shift, or if it is 2 shifts or 3 shifts per day, those things can be taken as a subgroup, or the subgroup size will consist of 1 shift production or 1 day's production or weekly production, like that. Okay. And as usual, the frequency also it is weekly you are going to take out or maintain, or daily you are going to take out the samples and maintain it, or shift wise. It depends on that. So if the quality, that is just like the control charts for variable, if the things are more these things, that means they are within the controllable range, then the frequency will be less. Otherwise, it is more. So initially, to begin with, more frequently the samples will be collected as it is implemented, and when the quality improves, at less frequency of these things, the samples will be collected. And again, the interpretation of the control charts for attributes is same as that of control charts for variable. Here, the control charts for attributes will also have 3 things: upper control limit, central line, and lower control limit. The same thing, same concept, no difference at all. No difference. So it becomes very easy to understand it now, because I'll be a bit faster so that we can solve number of problems. And by this initial brief introductions, we'll take up when I take up the numericals, that time those things will be made clearer. So in today's class, I am going to give certain introductory lecture about this control charts for attributes. Okay. So now, I said it will have again 3 things. One is upper control limit, again dashed lines, lower control limit, dashed line, the central line, it is the solid line. If all the samples, they fall within the control limits, yes, the process is under control, or if one of them, it falls outside the control limits, the process is out of control. Again, the same interpretation, whatever used, one side of the central line or other side of the central line, the same. That means out of 7, if we take consecutively 7, this thing, because let me recapitulate, when we were discussing about the interpretation of control charts for variables, we said if we consecutively 7 points, samples, they fall only on one side of the central line, even though they are within the control limits, then we need to stop the process and start to initiate certain investigation. Or again, out of 11 consecutive points, if one falls outside the control, outside the this one central line, more than one, then again we can stop. Out of 14, 2 are expected to fall outside one of these things, but otherwise other things might be in a random way. Or out of 17, 3 points, like that. Out of 20, 4 points, or the 4 samples, they can fall outside one side or whatever it is. Otherwise, it should be completely random. The same interpretation holds good for control charts for attributes. And usually in control charts for attributes, we are going to draw the connecting lines for the points. That means, for that one also we have said, that means I will go on connecting like this. The same thing is true. It should be truly randomized, otherwise it has to follow those things. Whatever we discussed, just like we discussed, these points where they should fall. Okay? These will give you certain differences and their similarities between control chart for variables and the attributes. Okay, friends? Now, I told you there are 4 types of control charts for attributes. In all these cases, similarly, we have to find out upper control limit, central line, and the lower control limit. Before that one, how we are going, these are the classifications these are given. Then, when the problem is given or when we want to introduce these things, which control chart for attribute is to be introduced? That is most important. Whether we are going to implement control chart, that is P type of control charts or NP type or C type or U type. You might have observed over here or in the previous class when I started, there also I had said, I had put them into 2 categories. You just see, because P and NP are one side and C and U are another side. Although all the 4 are attribute type of control charts. So if we look at P, P means what? P means it is for control charts for P, control charts for fraction defective. Try to understand, fraction defective. And I made it clear the difference between defective and defect. Because of one or more number of defects, an item can be classified as defective. That means a defective item will contain one or more defects. Then what is a defect? Each instance of not meeting the specification is called as the defect. So already we have discussed about that one in length, so I don't want to go in depth about it. Okay, this is what you just try to understand. So P chart means control charts for fraction defective. NP chart means, NP means what? N into P. That means this will give us, this is fraction. The fraction means less than 1. Try to understand. Okay, here P, NP, number of defectives. Fraction defective multiplied by the sample size. It will give us the number of defectives. While implementing, it becomes more easier. How? I can, suppose for example, upper control limit we have calculated. It works out to be 0.1. And lower control limit, it works out to be 0.05. Means what? That is what we need to understand. So we will take a sample of 100, let us say. We take a sample of 100. If it contains the number, because this is fraction defective, both are same. Upper control limit is 0.1 and lower control limit is 0.05. But again, the hinged point is the number of defective, because it has got a fraction defective of 0.1 and fraction defective of lower control limit as 0.05. Perfectly, it can be understood by an engineer or a statistician or whatever it is. But usually, it can be understood even by the layman. How? 100 samples if I take, the number of defectives can vary from how much? 5 to 10. 0.1 is 10% of 100 samples. It is lower this thing is 5. That means if it contains between 5 to 10 number of defectives, then it will be accepted. Process is going on. So the variation observed is normal. So there is no cause for worry. But if I find out, when I take out of a sample of 100, if I find the number of defectives as 11, okay, it is not 0.1, it has become 0.11. That means the production, something is wrong because it has fallen outside the control limit. The process is to be stopped. Okay, try to understand. Now 0.05, but I am getting around 0.04 or 0.03. That means I find when I take a sample of 100, it contains 2 defectives or 3 defectives or 1 defective. What does it mean? What should I do? So that question you might be getting in your mind. I can perfectly understand. If it is between 5 to 10 defectives, okay, I can understand. If it is more than 10, I can understand. If it is less than 5, why the process is to be stopped? Is it not? You are getting some clue about that one? Because it is getting, I am getting frequently when I take, it contains 2 defective or 3 or 1. That means it is lower than the lower control limit. That means the point has fallen this. And we said one thing, the moment it is outside the control limits, the process needs to be stopped. Is it advisable to stop here in this case? What is your way? In control charts for variable, we could understand that. But what is your inference for here? Because we are getting the quality, this thing quality much better than what we envisaged. Then still, as per the norms, it needs to be stopped and the investigations are to be made. Okay? This time, why it is to be made? Earlier, if it doesn't, if it falls above the control limits, upper control limits, yes. Why the defective items are being produced? Is there any assignable cause? So I should stop. Otherwise, if I leave it as it is going to be detrimental to the company or the organization. But when we are producing good qualities, why again it should be stopped? Yes, again, why it should be stopped is, again, why we are producing very good quality? That investigation has to be made. What could be the reason? We might get certain things which can be implemented. Another thing is, unnecessarily we are spending more money towards this. Because as my dear students, I told you, the basic thing is what? It hinges on economical aspect. We might be spending more money towards producing good items. Even if we allow, okay, relax, no harm. Is it not? That is what it means. Because it doesn't come just like that free. The quality comes, it doesn't come free. But somebody said, he wrote the book, quality is free. That is a different aspect. That is what we need to. That is how the Japanese, they surged ahead of others. Okay? Even though that means, even though this one is lesser, it is okay, fine. Okay? And in any case, we can see that it will not take the negative value, fraction defective or percentage defectives or number of defectives. They cannot take the negative values. That is what I had also explained. Because these are defective, these things they are going to take, and actually if I want to find out, these are going to take the values in steps. That is true in terms of integers. I cannot find out 2.5 defects. Either it will be 2 defects or 3 defects. I cannot find. Percentage defective, okay. Fraction defective, okay, fine. But actually when I count, I cannot, it has to be some integer value which will be varying from 0, not less than 0. I inspected negative -2 items. I can't substantiate. I didn't inspect. That means 0. Okay, fine. Okay. So it has to be that in that case, whenever we talk about the attributes, we need to use the attribute type of probability distributions. So if I look at this is about these things, how to next again, as we established in case of control charts for variables, upper control limit, central line, lower control limit. There we said X bar chart, R chart or sigma chart. Here we used to write. But this used to take the values or whatever it is we used to find out. And the samples we used to compare here. Sample 1, sample 2, sample 3, sample 4, like that. The same thing. And this upper control limit and the lower control limits, they were placed on either side of the central line in case of control chart for variables. They were equidistant. I don't understand. On X bar chart. But on R chart, it was not so. It is similar to that. If you compare this control chart for attributes, then you are drawing and other things, when you are reading, it is almost similar to the R chart of control chart for variables, almost. So here, the upper control limit and lower control limits are may or may not be equidistant from the central line. And we will see further analysis how it is to be done. What are the, because when we go on studying now, this is the time for finding out or fixing out upper control limit, lower control limit and central line for all these 4 control charts for attributes. So I was talking about NP chart. That means control chart for number of defectives. Try to see. And we need to decide which control chart is to be used when. Appropriate decision. That means when I should go for control chart for variable, when I should go for control chart for attribute, because there are 4 types. Whereas only distinction, whether I should go for control chart for attributes or control chart for variable. When I decide to go for control chart for variable, then X bar is to be, chart is to be used. Then depending upon the collector, the available data, then I can use in conjunction with X bar, R or sigma. Whereas if I decide I should go for control chart for attributes, then I need to decide whether I should go for P chart or NP chart or C chart or U chart. Okay? It is not just control chart for attributes. That means don't be under the impression P chart only always. No. Okay, but I'll try to give you the tips. Okay? There you look for the wordings. Attribute, control charts. Okay. There it might be number of defectives or fraction defective or the defects, total defects or defects per unit, they will come into picture. Whenever the things data refers to defects, then go for C chart or U chart. Try to understand. If it is defects, okay, you can go for U chart without any problem. Okay, it will take some time, but U chart, it is universal chart if it is a defect. It contains a word defects. And this, you will go for C chart if these defects from one unit to another unit it goes on varying, or the sample size are different. Sample sizes are different in the sense what? One shift I'll take 50, in another shift I will take 100, in next shift, next day I will take 200 sample like that. If they will go on varying. And we are finding out the defects. Then you go for U chart without any thinking. But if this sample, it remains, area of opportunity remains same. That means every time it is 100 only or 200 only, whatever it is. Out of that one, numbers, we are trying to find out the defects contained in that. Then go for C. Otherwise, you can go for U chart. If it is number of defects, U chart. If it is the fraction defective, the word defective is used, always go for P chart. Don't bother much about it. It is right. Maybe in place of N chart, you might be using P chart. Okay, fine. There's nothing wrong. But where you should have used P chart, if you are using NP chart, that is wrong. Similarly, where you should have used U chart, you are using C chart, it is wrong. But in place of C chart, you can always use U chart. No distance. Only thing is, it might economically bit cost, that's all. Nothing more than that, or calculation much. But otherwise, there is nothing wrong. So that means what? In place of C, always you can use U chart, but in U chart, you cannot use C chart. And in case of defective, always you can use P in lieu of NP chart, but NP chart cannot be used in case of P chart if the P chart is to be constructed. No. Other way around is not true. That you need to find out. Okay, friends, you have understood about that one now? Okay, this is defective, I said. C, number of defects. Defects. U chart, defects per unit. So here I want to make certain distinction. Suppose a person is trying to find out the defects in a cloth. That area of opportunity usually it remains same. Because it may have a width of some 1 meter or 1.5 or 2 meters, whatever it is, 1 meter, and length, every length of 1 meter I am going to inspect. Every time. Or sometimes that area of opportunity, it will go on varying. Sometimes 1 meter, sometimes 2 meters, sometimes 3 meters like that. Area of opportunity, it varies. But you are going to sometimes, that means what? Number of defects you will find in one area, 1 meter by 1 meter, 1 square meter area. But sometimes you are going to find out 1 meter by 2 meter, that means 2 square meter area, or 3 square meter area, that area of opportunity changes. In that case, defects per unit is to be used. It is as simple as that. Okay. Again, in case of P chart, the number of or sample size, it goes on varying. Sometimes we take a sample of 50 and count the number of defectives. In the next shift, next day we'll consider 200 and then count number of defectives. So both we cannot compare, is it not? How can we compare here the number of defectives less when I take a small sample and compare it to large sample? We cannot do that. So you have to give, because it's the universal law, we have to give the equal opportunity for all. Okay? One more thing I want to drive at. You must be wondering now why I had discussed about binomial distribution, Poisson distribution. Might not have given much importance for hypergeometric distribution, okay, and normal distribution. Already we know how the normal distribution played an important role in case of control chart for variable. Here also, in control chart for attributes, it is going to play a role. But when we said that control chart for attribute, that means whether it conforms or it doesn't conform. Usually we do like that. So actually we will not measure also in the mass manufacturing. Actually the lengths will not be measured. We will be using go gauge and no go gauge. Actual measurements are not there. It has to have between these two limits. I'll take, say for example, diameter usually. That means the go gauge, it will be like this. Go gauge and no gauge. This side if I put it, go gauge if I say, it should enter. No gauge means it should not enter. Like that. So it is based on the smaller dimension, minimum material, it should have, this is maximum material. That's as simple as that, outside diameter. Right? Okay, of course, I'm talking about that. So what is the actual measurement? Whether it was 20.1, 20.01 or whatever, no. It will give between the upper specification limit or lower specification limit that is there or not. That is what we want. So it will be very fast. Because we can say that instead of measuring one accurate dimension, I can classify them into defective or non-defective, 10 these things, the articles, by using go gauge and no go gauge. So even if it is measurable characteristics, we will be using that. That is what I told you. That is how they will start with P chart. They can classify it as defective or non-defective. How much defective, I will not tell. Actual measurement only will tell what is happening. So that is what I told you. First they will go for control chart for attributes, then they will go for control charts for variables. Okay? This is another thing how the cost will be less by going for control chart for attributes. One more thing I told you, it can be classified, that is what I was discussing. Can be classified as an item, can be classified as a good item or a bad item, or defective item or non-defective item. That means we can find out in two ways. What are those things? It is yes or no. Is it a defective or non-defective? Whether it has got a defect, it doesn't have defects at way. That means defective or non-defective means two-way classifications. That is why we say that binomial. Bi means two. Or we say that it is dichotomous in nature. Dichotomous. Di means two, not di. Chotomous means cut. Whenever I cut, two parts. Every time I will go on doing that. So which will follow? The binomial distribution. Okay? And we know when we are going to apply the binomial distribution. when if P is large, okay, N is also large comparatively. P is large, we are going to use binomial distribution. When P is small, then we said Poisson distribution. When P is more, we'll go for P. When P is small, then we'll go for C, that means defects. So occurrence will be less, and defects, that classification we have to see. Okay? So usually this P chart will follow, or NP chart will follow the binomial distribution. So it is very simple. Then we said, what is the mean? That is what I had mentioned. What is the mean of binomial distribution and what is its standard deviation? Whatever those, I can understand. For binomial distribution, whatever the mean and standard deviation, it hinges on that. Similarly for C chart. I'll just leave that one, but I am going to cover it over here because this is some important thing. What is the time now? Okay, still I got some 5 to 7 minutes. Okay, I was discussing what I was discussing. P chart, that means binomial distribution. What is the mean and the standard deviation of binomial distribution? Mean, we find out, we said equal to N into P. And standard deviation, this is under root NPQ. And also we know that Q is equal to 1 minus P. Try to understand which one we should take Q and which one we should take P. Which is favorable to us? What we are interested in, favorable to us in the sense. Actually, you want many good items and few bad items. So our favorable thing is not, because why we are interested, we will never question usually why I am producing good items. No. Why I am producing defective items or bad items, which are not these things. Because we will always say, why the more number of students are absent when they are full? We will never ask these things. Got this one? So, the favorable thing for us is defective. That is why we say X is the number of defective items, which is favorable, and its proportion, P. It depends on that. Q is a good item, but since it will have only two outcomes, whether defective or non-defective, that means P plus Q will always make it 1. Hence Q is equal to 1 minus P. If I know P, I can find out Q. No problem at all. Okay, this is what it says. Okay, now this is what has happened. NP, mean is NP, standard deviation. And standard deviation, the mean is NP from the mean value, how much away it should be. We have seen in case of control chart for variable, it should be 3 sigma level away. Why 3 sigma? Why not sigma? Why not 2 sigma? Why not 5 sigma, 6 sigma like that? What could be the reason? Because I may have discussed or I might not have discussed, I don't know. Because it gives rise to 2 types of errors. Okay? One is type 1 error. Another one is type 2 error. Okay, these things usually you will be experiencing when we start to study about control chart for variables or control chart for attributes or even in acceptance sampling. Okay. Okay, my dear friends, you just see, because now we are studying about the fourth unit. Fifth unit is about acceptance sampling. There also this one is going to persist us. Okay. So I casually mentioned in the third unit when we are discussing about control chart for variables. But I am taking this opportunity to explain, because I might have explained, but still it becomes more prudent to explain about type 1 and type 2 errors. What is type 1 error? Type 1 error means what? Actually, the process is under control, because there are two things. What is the real thing? Okay, and what actually the real thing and what conclusions we draw. Actually, the process is in control, but we conclude based on the sample that the process is out of control. That is called as type 1 error. Actually, the process is in control, reality, process is in control. But based on the sample, we draw the conclusion that the process is out of control. Okay? When I take a sample and if I feel that process is out of control, what is that we'll do? We'll stop the process, try to investigate. And after investigating, we find nothing is wrong. So but it calls for that one on wastage of distance, so not much harm is done. But still it could have been avoided. Okay, this is what we call it as, this is the favorable error, type 1 error, try to understand. Even though it is error, it is favorable. Okay, that means what? We think when we make the friendship or whatever it is, we take some samples of, we study about that particular person and we feel that the person is bad. But actually he is good. Or we may conclude that he is untruthful. But actually he might be truthful. Is one thing. Which is much better than really that person is untruthful. But I will conclude that he is truthful based on asking few questions. Then it is going to cost us heavily. It is just like that. So in case of type 2 error, the process is really out of control. It is not producing the good items. But based on the sample, we say that no, it is perfectly okay. But in reality, it is not, it is out of control. But based on this is out of control based on taking the sample. This is what universal thing. Here also this is what out of control, it is producing bad items. But when I take a sample, that based on the sample, I say that it is within control. Which is not good, it is erroneous. So what should I do? How do I do? Based on placement of control limits, I said. These control limits are much smaller, almost 2 times smaller than process control limits. And these process control limits, these are to be, or the tolerance limits, or the